Saxon Algebra 1 lesson 85 continued. Sorry, my I'd plugged my phone into the charger, but it wasn't charging. I was getting a low battery notification, so I was looking to make sure that it was plugged. I've tried moving the charging cord to a different place on the power strip, and then I had the great idea to try turning off and on the power strip, which was a really great idea, but it cut my video. So I'm back. Okay, so we were going to try another example, and I was just saying that these stem and leaf and histogram plots aren't real difficult for most students to grasp. It's just a lot of numbers and floating around. Okay, 85.2. Find the range, median, mode, and mean of the data in this stem and leaf plot. And then it says, it shows us this. I'm going to copy it. And just like the one we just did, it has the same stems. You wouldn't necessarily have to choose the exact same stems, but in this pair of examples, it just happened to work out that way. Are these are the same exact numbers, aren't they? Okay, 5, 2, 7, 8, 9. Oh, sorry, I'm copying the wrong part. Never mind. That was the solution to the one that we did. So now this is a different problem. I read the right instructions, but I copied the wrong data set. As you can see, let me show you so you won't think I'm completely crazy. I read you this, and then I started copying these numbers instead of these numbers. Oops, my bad. All right, 84. 8, 9, 6, 8. Wait, what does that mean? There's 8 twice. That means 848 came up twice. In whatever, John doesn't give us a cute little story, so we'll just have to pretend. It was the weight of the gorillas at the zoo. So 2 of them weighed 848 pounds. I wonder how much a gorilla really does weigh. Somebody Google that for me. And tell me in the comments. Somebody comment on this video and tell me how much the average gorilla weighs. I want one weight for the average female and one weight for the average male. Full-grown gorillas. Lowland kinds, the kinds that are at the zoo here in Seattle. Okay, 2, 3, 7, 5, 2. I'm distracting myself terribly. 6, 6, 3, 3. Okay, so we're supposed to find A, the range. Well, this stem and leaf plot makes it really easy, especially if we would have done it my way and put these numbers in order, which I did not do because I'm trying to be chill about it, but the highest value we can easily see is 876. And then for the smallest, we just go up here and it would be 846 is the lowest number. So the difference is 30. So that's the range. That's right. The mode is the most popular answer. Well, let's see. There's a pair of 3s that represent 853. That we show 2 times. 862, we also have 2 times. And then 873, we have that 2 times. Oh, and we also have, look, I miss this one, 848. We have also 2 times. So, oh wait, there's 848, 853, 862. Oh, I know what the last one is. This is also one, right? 876. 2 times. So, we have 5 modes in this data set. What? That's a lot, right? It seems weird, but for what it's worth, there it is. How about the median? All right. Well, this involves a little bit of logic and counting. The median is the very middle number, right? And if we would have put them in order the way I wanted to, it would be really easy. We'd just count backwards and meet in the middle. But here we have to take into consideration the fact that they're not organized properly. But we can do this. Okay, the first 4 and the last 4 like cancel each other out, right? They're out of it. That's balanced. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that means that the lowest number in this row is going to be the median. And look, it's actually the right number, right? Because that's the lowest. That if I put these in order, it would go 2, 2, 3, 5, 7. So this is indeed the right answer for the median, the middle one. And then the last bit is the mean. Means we have to add up all of these numbers, and we can't, there's no quick and easy way to do it. We have to do 848 plus 849 plus 846 plus 848 plus 854 plus 852 plus 853 plus 853 plus 862 plus 863 plus 867 plus 865 plus 862 plus 876 plus 876 plus 873 plus 873 total divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Lord have mercy. I don't want to do that. Do you? Me neither. So you know what we're going to do? We're going to rely on John. I give you permission for this calculation only. I allow you to use a calculator. If the numbers, calculator, no, lator. Only if the numbers are disgusting. Like these. Okay? Only you may use it. In this example, it would add up to 1, 4, 6, 2, 0. So 14,000 divided by 17, and that is 860 would be the mean. That's disgusting. All right, and then the last problem is another histogram, 85.3. Look, I can't even talk anymore. This problem has drained me of my resources. The speeds of 40 cars as they passed a checkpoint are shown in the frequency distribution table below. Oh, so John already made the graph for us. So let me show it to you. It's down here. Histogram, not a histograph. I think I've been saying that wrong. How many cars had a speed greater than or equal to 25 miles per hour and less than 30? Okay, 25, and there's the ones that are going 30 or higher. So we want the ones that are equal to 25 or more, but also less than 30. So we're talking about these cars. So how many were there? We go across. Oh, there were 4. That's right. There's the answer up there. All right. What was the mode interval? Mode means most popular, right? Like mod pizza, which my daughters ordered on Friday night. So, you know, there's that. So which one's got the highest number of cars? Well, it's the tallest one, right? So it would be that one. It doesn't ask us how many. And so this is the group of cars between 30 that were going between 35 and 40. And yes, John writes, this is the 35 to 40 interval. Can you see that? No, you can't. I'm up too high. There's the answer. All right, now I go back to this. C, what percent of the cars drove at a speed less than 40 miles per hour? Okay, there's 40. So now we have to figure out how many cars drove less than 40. I'm going to jot that down on my notebook, which is out of sight right now, but I will show you in a minute. Okay, so less than 40. So the 25 to 29 group, that was 4. The 30 to 34 group, that's 10. The 35 to 39 group is these, and oh, that's 11. And we want less than 40. So those are the 3 that we need. Okay, goodbye book. You've served us well. So now I've written them down here. Oh, look. Oh, well, it's fine. This is the speed And this is the number that we're going that speed. And John wanted to know what percentage. Oh, okay. So that's how many cars. We can add that up. That's 25. But now we need to know how many cars in total. So that means we have to add the groups that were going from 40 to 44 and from 45 to 49 and from 50 to 54, and then it goes all the way up to 55. It stops. Okay, I'll show you. We have to get the number of these guys too so that we can do, because we have to do a percent. So we need to know the total in order to get the percent, right? Okay, so we got the first 3, and so now we're adding the second 3. This one is 8. This one is 6. And this little bitty one is just 1. The speeder in the group. Okay, get that out of the way. Okay, so here are our cars that we need for the total. So this adds up to 15. So the total number of cars is 15 plus 25, right? So that's 40. So the percentage of the group that we want, oh, this could be a freaking formula, right? It's P over 100 times the total group equals the special group. So we want to know the percentage. So P over 100 times the total group, which is 40, equals our special group, which is 25. Make sense? Okay, and then we could draw the picture. Oh, I'm really getting into this. This was under 40 miles per hour, and this was the 40 plus. This is the total group, also known as the of. These are the special groups, also known as the is. We know that the total group is 40. So what we're trying to figure, and we know this is 25, and we know this is 15, but we need to know the percentages. So there's our calculation. There's our freaking formula. To isolate the P, we need to multiply by the reciprocal because we have fractions, so we don't want to do any actual dividing. This is one I want to multiply by, so this will cancel. And that'll cancel top and bottom. If I wanted to reduce first, I could. I choose not to do that, but it's NBD. 140. Okay, now let's cancel our hearts out. This is going to be my zeros have gone a bit wonky. Oh no, we're fine. We're fine. We're fine. We're good. Okay, so what I did here was I reduced my zeros and then I multiplied through. 25 times 10 is 250. 1 times 4 is 4. And now we just want to divide that to simplify. Because I have a feeling that 4 is going to go into that. Well, we want the percent, so we have to divide it. That's not a percent. So we take 250, divide it by 4. That goes in there 6 times. 6 times 4 is 24. We subtract, we get 10. It goes in there twice. That's 8. And our decimal's right there. So that means that our percentage is 62.5% of the cars were going 25 miles. No, we're going under 40. Sorry, there were 25 of them that were going under 40. And so then we can just subtract this from 100 because the beginning always represents 100%. This would be what, 37.5%. All right, so that is our final answer. Percentage of cars. This was a callback to a problem from last year that I hope you still remember how to do. Sometimes just these freaking formula things can trip people up. I see it happen to adults in the normal world all the time. Not that this isn't the normal world, but I'm just saying these formulas will help you solve so many problems. It will help you calculate how much, if you're looking at a new snowboarding jacket that was $325, but it's 40% off, you can calculate the actual price of that and convince your mom to buy it for you way faster if you can do these calculations in your head, or, at least approximate them. Mom, are you kidding me? That is such a good deal. So this is such a real life tool, and we used it here in our histogram example. All right, this lesson has gone on way longer than it deserves to. I'm going to say this topic of leaf and stem, stem and leaf, and histograms comes up again and again, and it never gets any harder. So in the future, I am going to look forward to you guys being like, oh yeah, these are easy. I know how to do these. Okay, thank you. That's all. Goodbye.